Resultant of two simple harmonic motions. Resultant of two simple harmonic motions at right angles, same period but difference in amplitude and phase. Difference in amplitude and phase. Okay. Let the two similar harmonic motions of equal frequencies, equal period and wavelength be along x and y axis if their displacement at any time t be x and y and represented by x equal to a sine omega t. This is the equation number first, and y equal to b sine omega t plus phi. Okay. From equation first, sine omega t equal to x upon a, and cos omega t equal to under root 1 minus x square upon a square. From equation number 2, y upon b equal to sine omega t plus phi equal to sine omega t cos phi plus cos omega t sin phi, because sin a plus b equal to sin a cos b plus cos a sin b. Substituting the values of sine omega t and cos omega t, we have y upon b equal to x upon a cos phi plus under root of 1 minus x square upon a square sin phi. Okay. Then y upon b minus x upon a cos phi equal to under root of 1 minus x square upon a square sin phi. Okay. Squaring both sides we get squaring both sides we get y upon b minus x upon a cos phi whole square equal to 1 minus x square upon a square sin square phi. Y square upon b square minus 2xy upon ab cos phi plus x square upon a square cos square phi plus x square upon a square sin square phi minus sin square phi equal to 0. Okay. Then y square upon b square minus 2xy upon ab cos phi plus x square upon a square cos square phi plus sin square phi, that is sin square phi. Okay. Then y square upon b square minus 2xy upon ab cos phi plus x square upon a square equal to sin square phi. Okay. This represents the resultant motion of the particle. This represents the resultant motion of the particle, which in general and ellipse inclined to the axis of coordinates. Okay. Important cases. important cases. When phi equal to 0, then sin phi equal to 0 and cos phi equal to 1. Substituting in equation number 3, we get, this is equation number 3. Substituting in equation number 3, we get y square upon b square minus 2xy upon ab cos phi plus x square upon a square equal to 0. Okay? Then y square upon b square minus 2xy upon ab plus x square upon a square, that is 0. Then y upon b minus x upon a whole square equal to 0. Okay? Thus the resultant motion is a pair of coincide straight lines. This is thus the resultant motion is a pair of coincident. The resultant motion is a pair of coincident lines lying in coordinates first and quadrants third. Okay, of rectangles as shown in this figure, the straight line are inclined. The straight line are inclined. The straight line are inclined to the x-axis. Inclined to the x-axis at angles theta. Theta by theta equal to tan inverse b upon a. Tan theta equal to tan inverse b upon a. Okay. Case second. When phi equal to pi by 4, then y square upon b square minus 2xy upon ab into 1 upon root 2 plus x square upon a square equal to 1 upon root 2 square. That is y square upon b square minus root 2xy upon ab plus x square upon a square equal to 1 by 2. This represents an oblique ellipse. Okay. This represents an oblique ellipse. Okay. This represents an oblique ellipse. This represents an oblique ellipse 2b and 2a. Okay. This figure is represent oblique ellipse 2a and 2b. Okay. Next, case third number. Case third. 1 minute. Case third. When phi equal to pi by 2. Substituting in equation number third, we get y square upon b square minus 2xy upon 2xy upon ab plus x square upon a square equal to 1 by y square upon b square minus 2xy upon ab 2x, sorry, y square upon b square minus 2xy upon ab cos 90 degree plus x square upon a square equal to sin square 90 degree. That is y square upon b square plus x square upon a square is 1. That is x square upon a square plus y square upon b square equal to 1. This represents an ellipse whose major and minor axis coincides with the coordinate axis as shown in the figure. You can show on okay, 2b and this is 2a. Okay, this represents an ellipse whose major and minor axis coincides with the coordinate axis as shown in this figure. Okay, shown in this figure. Special cases. Special case. If the amplitude are equal, that means A equal to B, then x square upon a square plus y square upon a square, that is x square plus y square equal to a square. This represents circle, radius A. This represents circle. This represents circle. This represents circles. Okay. This represents circles. Radius A. This represents circles. Okay. This represents circles, and the resultant motion is circular as shown in this figure. Case 4. When phi equal to 3 pi by 4, the equation reduces y square upon b square minus 2xy upon ab cos 135 degree plus x square upon a square, that is sin square 135. This is a y square upon b square. This is y square upon b square minus 2xy upon ab minus 1 upon root 2 plus x square upon a square, that is 1 upon root 2 whole square, that is y square upon b square plus root 2xy upon ab plus x square upon a square, that is 1 upon 2. This equation represents an oblique ellipse lying in coordinate second and fourth. Line and coordinate second and fourth. B and this is 2a. This equation is an oblique ellipse lying in coordinates second and fourth. Okay. Case fifth. Okay. When phi equal to pi c, equation 3 reduces reduces to y square upon b square minus 2xy upon ab cos 180 degree plus x square upon a square equal to 0. The resultant y upon b plus x upon a whole square equal to 0. Okay? This equation, this is 2a, sorry, 2b and 2a. This equation represents a pair of coincident straight lines lying in coordinates of second and fourth. Coordinate second and fourth. Coordinate second and fourth as shown in the figure. After this whole cycle is represented in the reverse order as shown in the figure. Okay? After this the whole cycle, is repeated, whole cycle is repeated in the reverse order as shown. You can show this is phi equal to 0 degree, 2a, okay, 2b, 2b, okay. Second, phi equal to pi by 4 radians. That means pi by 4 radians. That means the figure is in second and fourth coordinates. Okay. Next is phi equal to pi by 2 radian. Pi by 2 radian. The figure is ellipse. The figure is ellipse. Okay. Next is the angle phi equal to 3 pi by 4 radians. Then the figure is like this. Okay. Next is phi equal to pi radians. The figure is straight line in second and second and fourth coordinates. Okay. And after phi equal to pi by 4 radians. Phi equal to pi by 4 radians. Okay. Phi equal to pi by 4 radians. Pi by 4 radians. Okay. Then after some time, phi equal to 3 pi by 2 radians. That is the figure is oppositely moved in the same shape. Okay. If the phi equal to 7 pi by 4 radians. The figure is in opposite directions. Okay. And the next is phi equal to 2 pi radians. The figure is straight lines. Okay. These figures are called as Lissajous figures. These figures are called as Lissajous figures. Okay. Thank you.